Students, in this lesson or in this video, we are going to discuss very important and interesting topic, that is distinguish between SN1 and SN2 reactions. In the chapter of halogen derivatives, we have SN1 mechanism and SN2 mechanism. We know that the long form of SN1 and SN2 mechanisms as follows. S stands for substitution, N stands for nucleophilic, substitution nucleophilic, 1 is for unimolecular and 2 stands for bimolecular. Therefore, SN1 is named as substitution nucleophilic unimolecular reaction mechanism and SN2 stands for substitution nucleophilic bimolecular reaction mechanism. Mechanism means step-by-step progress of our chemical reaction. In this SN1 and SN2 mechanism, we have studied its example, its kinetics and various factors which affects on it. And at the end we have studied stereochemistry of SN1 as well as stereochemistry of SN2 mechanism also. Energy profile diagram is also important factor of this SN1 and SN2 reaction mechanism, and in this table we are going to see some distinguishing points of SN1 and SN2 reaction mechanism. Some points you may find like comparative also. So let us start with one by one which factors we have taken for consideration in this distinguishing format. First point is SN1 mechanism, two-step reaction. SN2 mechanism, it is one-step reaction. Students, we know that in SN1 mechanism, after the reaction between tertiary alkyl halide with NaOH, we get carbocation, and after carbocation gets converted into final product. Therefore, it is said to be two-step reaction. Here we don't get carbocation, therefore it is said that one-step reaction. Students, it is unimolecular reaction. Afterwards we are going to explain why it is unimolecular, or it is first order reaction. Here SN2, it is bimolecular reaction, or it is said to be second order reaction. We know, students, order of reaction is dependent on the rate of reaction, depends on how many reactants concentration. In short, in SN1 reaction mechanism, rate of this reaction depends on concentration on only one reactant species. I will repeat. Rate of this reaction mechanism depends upon concentration of only one reactant species, that is alkyl halide. Therefore, it is said to be first order reaction. Here, rate of reaction depends upon concentration of both reactant species. Both reactant species means concentration of alkyl halide as well as concentration of base or alkali we have taken. Generally we take NaOH. So both reactant species concentration affects on the rate of reaction, therefore it is second order reaction. It is first order reaction and second order reaction. Fourth point is, in SN1 reaction mechanism, simultaneous back and front side attack. Simultaneous back side and front side attack, and here only back side attack is favorable. Students, if you remember, in SN1 mechanism, at the intermediate state, we get the carbocation, and carbocation means carbon and three alkyl groups attached to it. And students, there are same space from all sides for the attack of nucleophile. Therefore, simultaneous backside as well as front side attack is favorable in case of SN1 mechanism. But here, only backside attack is favorable. Only backside attack means here carbocation do not form. Why carbocation do not form? Afterwards we are going to see that simultaneous making and breaking bond, or that first bromine goes and then OH attacks. Here simultaneous making and breaking bond takes place. Therefore, at the time of attack of nucleophile, you don't have carbocation and only backside attack is favorable due to the steric hindrance. To avoid that steric hindrance, backside attack is favorable in case of SN2 mechanism. Fifth point is, in SN1 mechanism, only tertiary substrate is good for SN1 mechanism. Tertiary substrate holds good for SN1 mechanism, and in SN2 reaction mechanism, mainly primary substrate holds good for this reaction. Sixth point is 50% inversion and retention of configuration. 50% inversion and retention of configuration means when backside and frontside attack takes place on the substrate or on the carbocation from the nucleophile, students, we get two products. One product is with inversion of configuration and one product is with retention of configuration. We have already studied when inversion of configuration product and when retention of configuration takes place, and therefore we get two products, and afterwards we are going to see how we get that racemic mixture also. Here only backside attack is favorable, therefore we get only one type of product, and that product is as 100% inversion of configuration. 100% inversion of configuration means dextrorotatory will become levorotatory and levorotatory will become dextrorotatory, because 100% inversion of configuration takes place in SN2 reaction mechanism.
Start.
Next point of this distinguishing format, students, forms racemic mixture. In SN1 reaction mechanism, racemic mixture is formed. We know, students, due to simultaneous backside and frontside attack, we get two different products. One product, if it is dextrorotatory, other will be automatically levorotatory, and both will be in same amount and with same concentration. Therefore, ultimately there will be a racemic mixture, means that mixture will be optically inactive. Here, as I said, only backside attack is favorable, therefore we get only one product, and then that one product shows different different properties than its reactant. Therefore we get opposite enantiomer formation in SN2 mechanism. Polar solvent favorable. Whatever solvent we use in SN1 mechanism, polar solvent is favorable, and in SN2 mechanism, non-polar solvent is favorable. We know, students, polar means due to difference in electronegativity, distribution of charges takes place, and here there is no such big value of big difference of electronegativities in non-polar solvents. Ninth point, two values of energy of activation. If you remember the energy profile diagram of SN1 mechanism, we have two peaks in that diagram, and therefore we have two values of energy of activation. Every peak will have separate value of energy of activation. In case of SN2 mechanism, we have only one peak in energy of that energy profile diagram. Therefore, we have only one value of energy of activation. 10th point is carbocation intermediate. I told you in previous part only that carbocation formation is the characteristic step of SN1 mechanism. In SN2 mechanism, no intermediate. Therefore, because it is simultaneous making and breaking bond takes place, therefore no intermediate is possible in case of SN2 mechanism. Here, first carbocation formation takes place, and then the attack of nucleophile will take place. Next point is weak nucleophile is favorable. Means whatever nucleophile means alkali we take, that weak alkali or weak nucleophile is favorable in SN1 mechanism, and strong alkali or strong nucleophile is favorable in case of SN2 mechanism. Here, this is the order of substrate of SN1 mechanism. The most favorable substrate is tertiary alkyl halide you can say, then secondary and primary. Tertiary alkyl halide holds good for SN1 reaction mechanism, then it comes secondary, and lastly it is primary. In case of SN2 reaction mechanism, the order of favorable substrates is as follows. Most favorable substrate is primary, then it is secondary, and third is tertiary. Therefore, order is primary substrate, most favorable, then secondary substrate, and then third tertiary substrate.